Most people don't realize that Starship is nowhere near its operational stage. We are still years away from seeing this rocket reliably carry humans or even payloads into space. What makes this development so difficult is that Starship is the largest rocket ever built, and SpaceX has no existing blueprint or example to follow. Every step forward comes through trial and error, with real-world testing being the only way to figure things out. While SpaceX has made tremendous progress, major challenges remain, and the recent Flight 8 is a perfect example of the hurdles they still face. This latest launch ended in failure, with the ship losing control and ultimately exploding. The issues uncovered in this flight have forced SpaceX to make some tough decisions about this version of Starship, decisions that may even lead to its cancellation. In today's video, we'll break down what went wrong, what it means for the future of Starship, and why this could be the turning point for an entirely new version of the rocket. But before we dive in, make sure to subscribe to our channel to stay updated. About a year ago, SpaceX came up with a smart idea to make the development of Starship easier and more structured. Instead of constantly making small adjustments to their design, they introduced the concept of versions, officially labeling their progress as Starship 5.2 and V3. The reason SpaceX introduced versions is simple. Starship is the largest, most powerful rocket ever built, and there is no past example to follow. Every single aspect of this vehicle has to be figured out from scratch through trial and error. With a fully stacked height of 121 meters and a planned thrust of over 7,600 metric tons, Starship is designed to carry massive payloads to orbit, refuel in space, and eventually take humans to the Moon, Mars, and beyond. However, turning this vision into reality is far more complex than anyone initially thought. Before SpaceX started labeling versions, they followed an experimental approach using prototypes. The early SN or serial number prototypes like SN5, SN6, and SN8 to SN15 were used to test key flight maneuvers, such as the belly flop and landing sequence. While some of these test flights ended in explosions, they helped SpaceX refine Starship's aerodynamics, landing legs, and control surfaces. After SN15 successfully landed, SpaceX shifted away from small-scale prototypes and began testing full-stack Starships with Super Heavy boosters. This was the beginning of Starship 5.1. The first major full-stack launch, called the Integrated Flight Test in April 2023, was an exciting moment but ended in catastrophic failure. Starship failed to separate from its booster, leading to a destructive loss of both vehicles. It became clear that hot staging, a method where the upper stage ignites its engines before completely separating, would be needed for more efficient stage separation. This led SpaceX to introduce Starship 5.2, which included major upgrades such as hot staging rings, improved Raptor 2 engines, and stronger heat shields. V2 first flew in Flight 7, using Booster 9 and Ship 25, and then in Flight 8, using Booster 10 and Ship 34. These flights demonstrated significant progress, particularly in catching the Super Heavy booster using the Mechazilla arms. However, the Starship upper stage failed in both flights. Flight 7 saw a fuel leak leading to an explosion, and Flight 8 experienced engine failures and loss of control. These failures have put Starship 5.2's reliability into question. The repeated pressure issues, fuel leaks, and failed engine ignitions suggest that V2's design might not be good enough for operational missions. This is why V3 is becoming more urgent. V3 is expected to be a major improvement over V2, addressing many of the problems seen in recent test flights. One of the biggest upgrades will be the transition from Raptor 2 engines to Raptor 3 engines. The Raptor engine series has gone through multiple iterations, with each version improving performance. The original Raptor 1 engine produced around 185 tons of thrust and had a complex design that made manufacturing difficult. Raptor 2 improved on this by increasing thrust to about 230 tons and simplifying the overall structure, making production faster and more cost-effective. However, it still had issues with occasional fuel leaks. Raptor 3 will take these improvements even further by pushing thrust beyond 250 tons per engine and increasing chamber pressure to over 330 bar. This means more power with better efficiency, allowing Starship to carry heavier payloads while using fuel more effectively. Another key upgrade in Raptor 3 is a more reliable ignition system, which will help prevent failures like those seen in Flight 7 and 8, where certain engines failed to ignite at critical moments. By making these changes, SpaceX hopes to reduce the risk of engine failures and improve long-term reusability. Another important change in V3 is the increase in fuel capacity. In V2, the Super Heavy booster could hold around 4,050 tons of propellant, while the Starship upper stage carried about 2,300 tons. In V3, these numbers will be increased to over 4,500 tons for the booster and around 2,500 tons for the upper stage. This additional fuel will allow Starship to fly further, carry heavier payloads, and improve refueling efficiency in orbit. The heat shield is another area where SpaceX is making significant changes. One of the biggest weaknesses of V2 is that its heat shield tiles often fall off or burn up unevenly during re-entry. Since Starship must endure extreme temperatures exceeding 1,600 degrees Celsius when returning to Earth, the heat shield must be both strong and reliable. SpaceX has observed multiple issues with the heat shield in past test flights, including tiles detaching mid-flight and areas of excessive heating leading to structural damage. V3 will introduce stronger attachment methods to prevent tiles from falling off, use higher heat-resistant materials to reduce erosion, and improve aerodynamics to minimize stress on the heat shield. Another improvement in V3 is the redesign of the hot staging system, which is the method used to separate the upper stage from the booster. In previous test flights, hot staging has caused pressure buildup and damage to the lower part of the vehicle. To fix this, SpaceX will reinforce the hot staging ring, modify the engine startup sequence to reduce stress, and strengthen the inner stage structure to prevent damage during separation. These adjustments should make stage separation smoother and more reliable, preventing failures that have affected earlier test flights. In addition to these major upgrades, SpaceX is making general improvements to Starship's structure. The materials used in V3 will be stronger and more heat-resistant, with thicker stainless steel walls to handle higher launch pressures, greater aerodynamic forces, and more extreme heating during re-entry. Now, many of us might be wondering about the next flight of Starship. After the failure of Flight 8, SpaceX is preparing for Flight 9, which will be another critical test for the program. The latest reports suggest that Flight 9 is expected to take place in mid to late 2025, depending on regulatory approvals from the FAA. Flight 9 will likely feature Booster 11 and Ship 35, both part of Starship 5-2, though some modifications may be made based on previous flight data. Booster 11 is expected to have improvements in engine reliability, fuel pressurization, and structural reinforcement, while Ship 35 will focus on hot staging, heat shield durability, and orbital operations. One of the key objectives of this flight will be to test full recovery operations, including catching the booster and further refining the reusability process. The flight will also contribute valuable data for NASA's Artemis program, as well as commercial partners who plan to use Starship for satellite launches and future space missions. That's it for today's video. Thanks for watching.